Hello, everyone, and welcome to my presentation. My name is Kristin Gibson, and I'm a doctoral student at the University of Georgia in the Department of Agricultural Leadership, Education, and Communication. I'd like to give a special thanks to my co-authors, Dr. Millicent Oyugi and Dr. Alexa Lamm. The title of my presentation is Advantages and Foundational Issues Associated with Using Structural Equation Modeling, or SEM, in International Agricultural Education Research. International agricultural education researchers are often interested in predicting motivations behind behavioral engagement of an individual or group. Structural equation modeling, or SEM, allows researchers to test hypotheses regarding the relationship between manifest and latent variables. SEM has become a popular data analysis technique among researchers, especially in relation to sustainability issues like those found in the agricultural context. Numerous international agricultural education studies have used SEM in their methodology. For example, one recent study used an SEM guided by protection motivation theory to explore climate change adaptation intention of farmers in Vietnam. Another study used SEM guided by theory of planned behavior to determine native farmers' support for policy to reduce agricultural water use. In addition, one study used an SEM to test the combination of the diffusion of innovations theory with the spiral of silence theory in the context of attitudes towards genetic modification foods. Purpose and research objectives. So guidelines and practice for SEM are generally presented in the research in the broader field of psychology. Few studies in the context of international agricultural education have elaborated on the advantages and foundational measurement issues related to SEM. Without acknowledging inherent SEM issues, international agricultural education researchers may misinterpret SEM and the implications resulting from the analysis. Therefore, the purpose of this methodological study was to determine the advantages and measurement issues associated with using SEM in international agricultural education research by conducting a thorough analysis of the literature and applying it to the international agricultural education research context. Two research questions guided this study. First, what are the advantages and disadvantages of using SEM in international agricultural education research in the social sciences? And second, what are the foundational measurement issues and common mistakes of using SEM in international agricultural education research in the social sciences? Advantages and measurement issues were determined with the guidance of Klein 2011. Overview of SEM methods for the social sciences. SEM is a multivariate data analysis technique that examines the relationship among manifest and latent variables. Latent variables, which are observed and therefore not directly measured, are often the variable of interest in social science research. Latent variables represent their associated hypothetical constructs. Manifest variables, which are observed and can be measured in a questionnaire, are often used to measure latent variables. There are also error terms known as residual associated with the dependent latent variable and the manifest variables. So an example of SEM in the social sciences. The theory of planned behavior is widely used to predict intention and/or behavior using SEM. The most basic theory of planned behavior model has 5 latent variables, which are attitude, subjective norm, perceived behavioral control, intention, and behavior, that are all measured by some number of manifest variables. Latent variables are denoted with circles or ellipses, and manifest variables are denoted with rectangles or squares. For example, in the theory of planned behavior path diagram displayed in figure 1, attitude is a latent variable, and attitude 1 through attitude 7 are the manifest variables used to measure the latent variable attitude. The arrows between the variables show the direction of the relationship between the variables. Double-headed arrows indicate a possible correlation between two variables as seen between attitude, subjective norms, and perceived behavioral control. Residual is denoted with a small circle. Behavior, intent 1, and intent 2 have residual associated with them because they are dependent latent variables. Residual is also associated with all manifest variables. The number 1 on the arrows is their associated factor load. There are numerous advantages of SEM. Notably, SEM allows researchers to develop complex models, is flexible, tests the null hypothesis for model fit, and represents measurement error. One study discovered that SEM may provide a framework for multidisciplinary teams. So first, SEM is complex because it allows the researcher to develop a system of regression equations that create a model rather than single, simple, or multiple linear regression. Specifically, multiple regressions test model components separately using an equation by equation basis. SEM, on the other hand, tests a series of linear equations that allow researchers to make a decision about the whole model. SEM is therefore considered more powerful than conventional regression analysis, as there is a higher probability of rejecting a false null hypothesis than regression. SEM is flexible because it allows researchers to develop complex models that measure direct and indirect effects of an independent variable on a dependent variable. Direct effects are regression relationships where one variable is linearly related to another variable. Indirect effects entail a covariance relationship and a regression relationship. Testing the null. Researchers using SEM test the theoretical model they are interested in directly because the SEM theoretical research hypothesis aligns with the null hypothesis when testing for model fit using chi-squared. Thus, the researcher does not want to reject the null hypothesis for a chi-square model fit because it would indicate the theoretical research hypothesis failed. Measurement error in SEM is explicitly represented, which is a limitation of many other statistical methods. Statistical techniques like multiple linear regression assume independent variables are without error. The ability of SEM to represent error lends a more realistic quality to an analysis. Studies have also argued that SEM provides a critical framework for multidisciplinary research teams who are addressing grand challenges like agriculture and climate change. According to Smith et al., SEM provides a common framework across disciplines, facilitating constant refinement of hypotheses and methods, and promoting discovery of new questions and relationships, which may help bridge the gap between multiple disciplines working on a common project in natural resource conservation. There are also several measurement issues and common mistakes associated with SEM that researchers often overlook. Some notable issues include the misuse of model fit indices, psychometric characteristics, sample size, correlation versus covariance matrices, theory, and confirmation bias. Model specification is also a common issue in SEM, but it requires a greater understanding of SEM than presented here. So model fit indices. SEM analyses should test a theory rather than find a model that fits the data. Model fit can be maximized by introducing additional paths and error, but it may not make sense theoretically. In addition, there are numerous model fit indices that should be examined and considered when evaluating a hypothesized model, including chi-square, goodness of fit index, adjusted goodness of fit indices, comparative fit index, standardized root mean squared residual, root mean square residual, and the root mean square error of approximation. However, there's a debate in the SEM literature as to the best strategies for assessing model fit. Some researchers ignore chi-square altogether, while others use it frequently for assessing goodness of fit. Not using chi-square at all is considered bad practice, but it should not be used alone due to its sensitivity to sample size. Psychometric characteristics. SEM requires strong psychometric characteristics, including evidence of reliability, validity, and measurement invariance. Often, measurement invariance is overlooked in SEM models, making it impossible to know if the latent variable represent their associated hypothetical constructs. Bias will result if the psychometric characteristics of a latent variable are not strong. Regardless, while latent variables represent constructs, they are still approximations and should be noted as such. Sample size. SEM requires a large sample size that may not always be possible to collect in the international agricultural context. Estimation problems and unreliable results are likely to occur if there are less than 10 observations per variable. However, there is no standard minimum sample size for SEM that is applicable in all contexts, but rather a 5 to 10 times the number of indicators rule of thumb. Given such, more complex models or models with more parameters will require a larger sample size than fairly simple models. Although there's no standard minimum sample size for SEM, the median sample size for SEM in published articles is around 200 cases. It's important to reiterate that this may be too small if the model analyzed is complex, the estimation method used is one other than maximum likelihood, or there are non-normal distributions in the data. SEM theory pertains to covariance matrices. Yet many studies use a correlation matrix instead of a covariance matrix or do not specify the matrix used. Generally, there are inaccurate standards of error or parameter estimates when a correlation matrix is analyzed for the SEM. Yet, a review of SEM studies have found that correlation matrices are often used or that it is unclear whether a correlation matrix or a covariance matrix was used for the study. SEM is theory-driven. It requires an expert knowledge of theoretical and empirical literature in the associated field. The model should be determined prior to collecting data so that there is theoretical significance in the study, not just statistical significance with no meaning. Lastly, confirmation bias. Alternative models that may account for the same amount of covariance must be considered in SEM. Without considering alternative models, other explanations of the data are not explored and therefore contribute to confirmation bias. Dividing the data into 2 or more sets to determine if the estimated model in one data set aligns with the estimated model in another data set is one way to validate the data set. End discussion. Considering the advantages of SEM over other statistical techniques like those in the GLM, researchers should capitalize on the strengths of SEM. However, there are measurement issues that new or untrained SEM researchers must be aware of so that management decisions for or communication about international agriculture are not misrepresented. Professional development opportunities related to the use of SEM offered through professional organizations like AIAEE may assist research teams in using SEM correctly and the implications of their associated findings. It is impossible to assume a researcher can learn everything about SEM in one professional development opportunity, but professional development opportunities provide a base point for two-way communication and other learning opportunities. There are also numerous videos on the internet that researchers can use to supplement their professional development session, but it is important open dialogue is available considering the complexity of SEM. In addition, the large number of videos on the internet describing SEM may make it difficult for a researcher to determine where to spend their time. So professional organizations should determine the most applicable videos for their field and link them to their website or newsletter. Professional organizations may also want to consider creating their own videos and describe SEM because they will be tailored to the needs in the specific field. Finding a commonly used theory, relatively easy to use software program, and describing each step and common issues associated with each step would be a valuable resource for researchers interested in SEM. As social sciences researchers who study international agriculture continue to address grand challenges in the 21st century, working on interdisciplinary or transdisciplinary teams will become the new normal. Smith et al. Proposed a novel idea for SEM in that SEM may bridge the gap across disciplines, therefore transcending the idea of single discipline teams. Considering the amount of jargon associated with different scientific disciplines, having a common language for project design and implementation that is also supported by funding agencies is essential to team success. Future research and conclusions. Future studies should assess social science researchers who study international agricultural self-efficacy associated with using SEM. A survey of social science researchers in the field may help more accurately determine common mistakes made in SEM, as well as why researchers decide to use SEM as their methodology, which may help create a more exhaustive list of advantages and mistakes than presented in the current study. Lastly, SEM is a rigorous research framework that may help address grand challenges, but researchers need to be knowledgeable about SEM in order to capitalize on its strengths. Thank you so much, and feel free to email me with any questions.